going on, y'all? Welcome back to Math Partake. So today I will be showing and explaining to you how to prove that two balls are disjoint. Before starting, it's important that you know the definition of the word disjoint. So disjoint just means that two or more sets have no elements or no points in common. Well, let's say if I do circles instead. 1 and 2. They're separate from each other. They don't intersect. They don't touch. That would mean that the two balls are disjoint. So in this example, we're going to prove the following theorem. The theorem says that if the distance from point X to point Y is greater than 8, then a ball that's centered at X and has a radius of 4 and a ball that's centered at Y and has a radius of 4 are disjoint. The first stage of the setup is to write your given and your show. The point of the given is to really just restate the if statement at the top. Distance from point X to point Y is greater than 8. That is your given. Next, you're going to write your show. This is what you're going to prove, all right? And this is always going to be your then statement. So show the ball from X to 4 and the ball from Y to 4 are disjoint. So that's stage 1 of our setup. Now let's go on to stage 2 of our setup, where we're going to choose the type of proof. We're going to use a proof by contradiction, also known as an indirect proof. Now, I'm choosing this because the proof by contradiction and allow us to look at the show statement and blatantly challenge whether that statement is true or false. Now, I can take an opposing view, which in this case will be the opposite of the show statement. So where it says the ball from X to 4 and the ball from Y to 4 are disjoint, the opposing statement would be the ball from X to 4 and the ball from Y to 4 are not disjoint. At this point, the proof, which we're going to get into, is going to serve as somewhat of a fact checker for the opposing view, the not disjoint view. And as I'm stating and numbering the facts that support this opposing view, at some point, I plan on coming across a fact that contradicts something that's inconsistent or opposes what was originally provided in the given statement. That contradiction will prove that the opposing view, which is the not disjoint statement, is wrong. Therefore, the original show statement will actually be proven and shown to be correct. And then at that point, we're done. Just put a little line underneath. All right, so line 1. Remember that we want to start off writing the opposite of our show statement. So what we can start off with is, for our line 1, we're going to assume on the contrary. Assume on the contrary. And we're going to write that the ball from center X to radius 4 and the ball from center Y to radius 4 are not disjoint. This is the opposite of the show statement. And then we're going to justify this first statement with what it will always be in a proof by contradiction, which is the indirect hypothesis. The opposite of the show statement is always going to be called and justified as the indirect hypothesis. I'm just going to write HYP for short. Now, what we have to understand is that each line builds and feeds off of each other. we're already talking about the balls not being disjoint. So let's stay there. Let's think about the definition of disjoint for line 2. And we talked about it earlier. If two items, in this case 2 balls, are disjoint, then that means that they don't have any points in common. This is also referred to as the balls having an empty set. However, take a look at line 1. Line 1 says that the balls are not disjoint. So, if we were looking to build from that statement, we can say for line 2 that the ball from X to 4 and the ball from Y to 4 is not an empty set. So I'm going to write for our second justification by the definition of disjoint. So far, so good. And remember, if something doesn't have an empty set, then that means what? That means at some point, they cross paths. And what's another way to say that something crossed paths with something else? You can say that these two things intersect. So let's write that down for line 3. So line 3, there exists a random letter. I'm going to choose Z. There exists a Z, which is a point, in the ball from X to 4 that intersects with the ball from Y to 4. And this is going to be by the definition of an empty set. So by def of, and I'll just use the symbol, empty set. You should now begin to notice the pattern that in line 1, we said that the balls are not disjoint. And then in line 2, because they're not disjoint, there's no empty set. And then because there's no empty set, there is a or many points of intersection. Let's go ahead and move on to line 4. Now we mentioned a point of intersection in line 3. We called it point Z. So what does it mean for point Z to intersect with both of these balls? Well, it means that, I'll put it in line 4, the point Z is in the ball X4 or X24, and the point Z is also in the ball from Y to 4. And if you guessed the justification being by the definition of intersection, you were right. 4. By definition of, I'll use the sign, the intersection sign to save space. So at this point, we've pretty much run out of all the necessary definitions to describe what it means for two items to not be disjoint. But math is specific. And we still haven't mentioned any definition or facts about the items that we're actually talking about, which are balls. For example, if I were to draw a ball and I said that this point is the center, and I'll call it X, our first ball is actually called ball X. And then I were to create another point, which is Z, and I'm saying it's within this ball, it has to be somewhere within the radius. So let's say if we made Z somewhere like right here. This means that if we say the distance from our center to the radius is 4, then that point Z must be less than the actual radius of 4. The distance between center X and point Z is less than 4, and the distance from center Y, this is in the other ball, to point Z is also less than 4. So by def of ball. Now, because we have inequalities in distance in line 5, we can now use that information to create and substitute into a highly used formula called the triangular inequality. So line 6 is going to say the distance from X to Y is less than or equal to the distance from X to Z plus the distance from Z to Y. This is by triangular inequality. Now, our next line is simple. We're just simply going to substitute in the value from step 5 into the formula written in step 6. So line 7 is going to say that the distance from X to Y is less than or equal to, and then you have the distance from X to Z, which we're going to grab from line 5, which is 4 or less than 4, plus the distance from Z to Y, which we're also going to grab from line 5. And that also is going to be a positive 4. And to finish this line off properly, 4 plus 4 is equal to 8. But because in line 5, we see that both the distance from X to Z and the distance from Y to Z are both less than 4, we're going to say that the distance from X to Y is going to be strictly less than the value of 8. And we receive this information by substituting what we have in step 5. Step 5. Okay, so now we see that our distance from points X to Y are less than 8. But hold on a second. Our given talks about the distance from X to Y also. Let's quickly write that given statement at line 8. The given says that the distance from X to Y is greater than 8. That justification is that this is our given statement. By given. Now, this is what we've been looking for the entire time. The given statement says that the distance between points X and Y must be greater than 8. But our line 7 says that the distance between points X and Y are less than 8. Now, that's inconsistency. Clearly, line 7 and 8 don't match. That's a problem, and it's also a contradiction. So my opposing statement, my indirect hypothesis from line 1, was actually wrong. And the original show statement is actually correct. So let me erase some of the stuff that I have here and show you a way to verify that a contradiction has occurred in your proof. So the way you're going to do this is you're going to draw a circle with an X in the middle of it. And you're going to simply write that line 7 says that the distance from point X to Y is less than 8. But our given statement which is line 8, shows that the distance from X to Y is greater than 8. This is a contradiction. Thus, the indirect hypothesis from our earlier line 1 is false. The ball from center X to radius 4 and the ball from center Y to radius 4 are disjoint. Q, E, D. Hey, thanks for watching. For more answers and help that you may need in math, subscribe to Math Partake.